Hello and welcome to this learning video. Here we are going to start with the very important and the easiest unit which students like the most is linear programming problem, and here we are going to have an introduction of this topic. So let us start with the basic things. So before I start with the basics terminologies, let me tell you the very wonderful applications of LPP. So the very first application that we have here is that the application of LPP is in food and agriculture. And why I have taken the very first application to be food and agriculture? Because this is the hot topic of this time. Okay, so there are various applications that we have in food and agriculture. The second application is engineering, which we use maxly in this optimization problem. So there are so many optimization problems where in the engineering where we make use of this LPP. And last but not the least, we have the application of LPP in transportation, manufacturing, and energy. As far as the civil engineering is concerned, there is a lot of application of LPP in transportation, and there is one special topic is there like transportation problem. How to, with the help of which you can learn how to maximize the profit or minimize the losses, okay, and make use of the available resources to the optimum. Okay, so these are the application. Now, after the applications, we have the basic terminologies, and these terminologies will be very helpful in understanding the things that we are going to learn under this topic. So the very first thing is general linear programming problem. In short, we will call it as general LPP. Okay. The second thing is objective function, and we have to deal with these things whatever I am covering under this basic terminologies. Okay. The third one is the constraints. Number 4, solution of the general LPP, feasible and optimum solution of general LPP. So without wasting time, let us start with this general linear programming problem. So here it is. So consider a linear function of z defined as this. Z is equal to c1x1 plus c2x2 plus cnxn, where all these c1, c2, cn are constant. We write it as cj equal to constant and j varying from 1 to n. Okay. Now let aij be a real matrix of order mn, and b1, b2, bm, all these are constants, such that a11x1 plus a12x2 plus a1nxn is equal to b1, a21x1 plus a22x2 plus a2nxn is equal to b2, and so on. am1x1 plus am2x2 plus so on amnxn is equal to bm. Say this set of equations to be equation number 2, and all these variables x1, x2 and xn are all greater than or equal to 0. Then what is our objective? Our objective is to determine the values of these x1, x2 and this x3, which satisfies this condition 2 and condition 3, and thus the problem so is called the general LPP. Okay. Now let's move on to the second thing. The second thing is the objective function. Okay. So the second thing is objective function. So the linear function that we have discussed in the last slide, the linear function of the type this z is equal to c1x1 plus c2x2 plus cnxn, which is to be maximized or minimized, is called as objective function. Okay. Next is the constraint. Okay, so what are the constraint? The non-negative restrictions that we have as equation 3, that is x1, x2, xn greater than equal to 0 is called as constraints. Okay, now the next thing is solution of the general LPP. So what is the solution of general LPP? An n tuple x1, x2, xn of real numbers which satisfies the constraints of a general LPP is called as the solution of general LPP. Okay. The very next definition is of feasible solution. This is one of the important thing when we discuss the solution of LPP by graphical method. Then this definition is very important. So let us see what this feasible definition of feasible solution is. Any solution of LPP which satisfies non-negative restriction of the given problem is called a feasible solution of the given LPP. For example, if x1 is equal to 1 by 2, x2 is equal to minus 1 and x3 is equal to 3, which is not a feasible solution. Why? Because as we have seen, any solution of the LPP which satisfies the non-negative restriction, but here as you can see we have the negative solution. We are getting the value of x2 to be minus 1, so this is not feasible. Okay, so what is feasible? This x1 is equal to 1, x2 is equal to 3 by 2 and x3 is equal to 2 as a feasible solution of the any LPP. Okay, at last, the very important thing that we have is the optimum solution. Some people also called as that optimal solution. Okay, so don't bother about the different names of the same thing. So any solution of the LPP which optimizes, meaning of optimization means minimization or maximization of the given objective function of the general LPP is called optimum solution. Okay, so the things that we have discussed here in this learning video are very helpful. So it's a suggestion from my side, you must go through this video lectures very nicely, go again and again at least one more time, and once you go through this video lecture, all the basic terminologies required to learn this topic in a very good way would be fulfilled. Okay, so just go through this video lecture. Okay, and at last we are going to conclude with this by the last slide. Thank you for watching this learning video and happy learning. Thank you.